Hey, welcome back. This is Calc 2. We're working in differential equations, and we're going to finally introduce separation of variables. We've kind of already been doing this, but we're making it now official. Right, so first, kind of just the technique, separation of variables. Well, the technique, and also we'll kind of introduce the form. So not all differential equations can be separated. Okay, that's the sad truth of the matter. It needs to kind of be in this form. Usually when I see them, it's not even like this. It's more like some stuff on one side, some stuff on the other. There's something called a differential form. Sometimes you'll see in the book or in class where they multiply everything by dx, and you get m of x dx plus n of y dy equals 0. So don't let that scare you or confuse you. It's nothing to worry about. Anyways, like I said, not everything is going to be separable. This is just only works for special cases of this form. So anyways, it's the title of the method kind of tells you how these work. Basically, you're getting all the x stuff on one side and all the y stuff on the other. Okay. So here we go with example 1. I'm going to move the x squared plus 4 to the other side, divide both sides by y, and then multiply both sides by dx. So you end up with dy all over y equals x all over x squared plus 4 dx. Then I'm going to integrate both sides. On the left, I get the ln of the absolute value of y. On the right, I'm going to have to do a u sub. So u for the denominator, x squared plus 4. du is 2x dx. So dx is du all over 2x. So I'll do my subs. So I have x over u times dx, which is now du over 2x. So ln absolute value of y. You can factor out on 1/2. The x's will nicely cancel, and you have the integral of du over u. Then I'm going to integrate that. I get the ln of the absolute value of u. Let's go ahead and back sub what u was. So u is x squared plus 4. And then plus our integration constant. I'm going to exponentiate both sides because I want an explicit solution. So I want y equals something, usually. Sometimes, as we maybe discussed before, implicit solutions are fine, but here you can get the explicit. So exponentiate both sides. On the left here, the exponential and the logs will cancel, and you just have absolute value y. On the right, you can't get a cancellation in this e to the 1/2 ln of x squared plus 4. You need to literally move that exponent inside the ln. Okay, so you get e to the ln of x squared plus 4 to the 1/2, or rather, square root of x squared plus 4. I won't need the absolute values because the square root of anything is just going to be positive. X squared plus 4 is always positive anyways, so you don't need the absolute value. And then instead of writing plus c, I'll write e to the c. Okay, that's just from our exponent rules. Then I can simplify the right-hand side now because the e and the ln will cancel, and you get the square root of x squared plus 4. Let's put the e to the c in front. And then you can drop the absolute values, replace it with a plus or minus, and you get e to the c square root of x squared plus 4. Then you can replace this whole thing with a constant c. So you just put c square root x squared plus 4. And that should be what they got. Yep. Okay, they go ahead and check their solution, plugging it back into the differential equation and making sure the left-hand side and the right-hand side are the same. So you can do that if you want. Here's an initial value problem, example 2. Let's take a look at that. And it's given in that weird differential form. Okay, so the differential equation xy dx plus, plus e to the negative x squared times y squared minus 1 dy equals 0. Okay, you can divide everything. You want to get it back into a separated form. Okay, so you want, ultimately, what you want is to have some function of y on one side, dy, and on the other side, you want some function of x. Let's give it a different name. Let's call it p of x, because it won't be m of x if we started in this form. It would be like negative 1 over m of x, or negative m of x. Right. So let's just put p of x instead. So you need all the y stuff on one side, all the x stuff on the other. You could start by dividing everything by dx, but I think it would be enough just to move this thing to the right. Okay, so let's start there. So I have e to the negative x squared times y squared minus 1 dy equals negative xy dx. Then I'm going to start moving the y stuff to one side, the x stuff to the other. So I have y squared minus 1 over y dy equals, and to move the e to the negative x squared, you can multiply both sides by e to the positive x squared, or you can divide both sides by e to the negative x squared. I'm just going to multiply both sides by e to the positive x squared. And then you integrate, okay, on both sides. On the left side, I'm gonna cut that integral into two parts. Y squared over y is y minus 1 over y. So I'll be able to integrate that. On the right side, you're gonna need a u sub for x squared. So du is 2x dx. And so dx is du all over 2x. Okay. I'm going to pull that negative out front right off the bat. There's an x, there's e to the u, and then there's du all over 2x. On the left now, I'll have y squared over 2 minus the ln of the absolute value of y. On the right, you'll have, well, I can factor out a negative 1/2, right? And then the x's will divide out, and you have the integral of e to the u du. Carrying on, I have y squared over 2 minus ln absolute value of y equals negative 1/2 e to the u, but let's back sub and just put x squared in there, shall we? And then plus our integration constant. See, this thing is kind of not going, I'm not going to be able to exponentiate both sides and then solve for y, and because of that y squared. You can play around with it and try to see what you get. And if you're interested in that, you can kind of Google and study that, how they get explicit solutions or whatever, or how, I think what's interesting is how they graph these things, because for a long time I couldn't graph it in Maple or Mathematica, but once Desmos came around, then you could start graphing this stuff. So learning how Desmos works might be a cool side project if that's what you're interested in. But anyways, I have an initial value somewhere. I guess I didn't write it down. So it's given in the book in example 2, y of 0 is 1. So what I'm going to do is use that initial condition to get the c value. I'm not going to have a nice looking answer like y equals something, okay? That's not going to happen. But okay, so y is 1. This is the x is 0. So I get 1 squared is 1 all over 2 minus ln of 1, which will end up being 0, ln of 1 is 0, equals negative 1/2. E to the 0 squared is 0. E to the 0 is 1. So let me rewrite that. So I'll have 1/2 equals negative 1/2 plus c. Add 1/2 to both sides, and you get c is 1. So our particular solution, y squared over 2 minus ln absolute value of y equals negative 1/2 e to the x squared plus 1. So that would be your particular. They put everything on one side and get rid of the fractions. That's not necessary. You don't have to do that. If you want to, that's fine. But okay, you can always, if you're worried about your solution, you can always check it. Okay, you can always, take the derivative and then plug it into this original differential equation and make sure it works. Okay, okay, and I guess you would have to rewrite. You can check this by differentiating and rewriting to get the original equation. Yeah. So yeah, you could check it. I guess you just start with this. They're not even saying plug it in. Okay. Let's see what else they got. So another one, example 3. Find the equation of the curve that passes through the point 1, 3. And has a slope of y over x squared at any point. So slope is just another word for basically derivative. I mean, slope, you probably learned in Calc 1, is the derivative. It's just, for functions, the derivative is a variable. So it's a variable slope formula. So here they're telling you the slope is y over x squared. And essentially that tells you a differential equation. Okay, so I want to solve this to get the particular curve going through the point 1, 3. So first separate. So I get dy over y equals dx over x squared. I want to integrate. So ln absolute value of y. Let's rewrite this integral as x to the negative 2 dx. So power rule, x to the negative 2 plus 1 is negative 1, and then it'll be divided by negative 1, which is the same as multiplying by negative 1, plus c. Then I'm going to, you can exponentiate this guy. So you're going to be able to get a nice looking answer. Absolute value of y equals e to the negative x to the negative 1 is the same as negative 1 over x. And then plus c. Drop the absolute value. You get a plus or minus over here. Of course, I'm going to rewrite this part of it as e to the c times e to the negative 1 over x. So you get plus or minus e to the c times e to the negative 1 over x. And then replace this part with your big constant c. So you get y equals c e to the negative 1 over x. And then use the initial condition to get the particular curve. So this solution represents a whole bunch of curves in the plane. This point tells you which curve, solution curve, that goes through the point 1, 3. So plug in 3 for y, and I get c e to the negative 1 over 1, so negative 1. Solve for c, so I'm going to multiply both sides by e to the positive 1. And I get 3e, and then you could plop it back into this equation and get your particular solution, right? So you get y equals 3e to the negative 1 over x times e to the 1, which you can rewrite as 3e to the 1 minus 1 over x, just using rules of exponents, okay? And that's pretty much what they did there. They found a common denominator and wrote it as 3e to the 1 over x over x minus 1 over x would be x minus 1 over x. Okay. Okay. The initial condition. So sometimes your solution will not be in the entire xy plane, but it will exist in an area around 1, 3. So they've presumed that our solution was in quadrant 1 and let x be greater than 0, and only really worry about the solution in that quadrant, which is fine. Okay, so there's their little picture, and you could go to Desmos and kind of get a picture of what you're dealing with if you want. Okay. Technically, the differential equation doesn't necessarily have a solution or even a unique solution, and you'll learn more about that if you took a more specific class in differential equations. And that's kind of why they're having this issue where they're trying to make x greater than 0. It'll turn out that if you have a differential equation where this thing dy over dx is not defined somewhere, like in this case, x equaling 0. You can't divide by 0, right? So the differential equation originally is like this. This means that basically you're not insured to have a solution at 0. So there's some question right there because of division by 0. And again, this is, even when I teach it in differential equations, they still sort of skirt the issue. They leave it for an even more advanced course as to why. So don't overthink it. It's kind of what I'm getting at. Why did they make x greater than 0? It's kind of technical. I wouldn't take off on a test if you didn't note that fact. I wouldn't expect you to note the fact at all because you just don't have enough information yet. Okay. So anyways, don't worry about that. This is the solution. That's what I would want to see. And I probably wouldn't ask for a graph on a test, but there's the graph. You could just do in Desmos. Okay. Okay, so there's that spiel. With regards to applications, there really aren't a lot in the homework. There's maybe one population growth, but there are. I did put those orthogonal trajectories in there. So let's look at working with those. So section, I guess this is just section 2. Orthogonal trajectories. So if given a differential equation, or even given a family of curves, like in example 5, what you're after is a family of curves such that when you draw that other family of curves on top of the original family of curves, all of the curves are perpendicular to each other. So orthogonal is just going to be another word for perpendicular. They also use the word normal in Calc 3. So those are all the same, right? Okay, so anyways, we want to produce another family of curves that is orthogonal to this given family. So the first thing you're going to do is solve for C. So first solve for C. So I'll get C equals xy. Then secondly, you're going to differentiate implicitly. So on the left, the derivative of C is 0. On the right, you have to do a product rule, so leave x alone. The derivative of y is 1, y prime. And then plus, take the derivative of x and leave y alone. Then you're going to solve this for y prime. So solve for y prime. This is our sort of method. So I'm going to move the y to the other side, and I get xy prime is negative y, and then divide both sides by x. Then I'm going to form a new differential equation. Produce a new differential equation. Let me just write dE for differential equation. A new dE that has perpendicular slope. Let me write that for perpendicular slope. So if you remember from algebra, you could tell that two slopes would be perpendicular if they were negative reciprocals of each other. So what you do is take this thing and just take the reciprocal of it and make it negative. So it would be negative x over y, in other words, positive x over y. Then you just solve the new differential equation for your new family, okay? So we're gonna have to separate. Remember, y prime is the same as dy over dx. Multiply both sides by dx, multiply both sides by y. You get y dy equals x dx. Integrate both sides, you get y squared over 2 equals x squared over 2 plus c. You can make it look a little prettier, multiply by 2, y squared equals x squared plus 2c, but we'll just turn that into c. Move the x squared over, and you get a family of hyperbolas. Okay, so I guess the original family would be a bunch of things like this, or even things like this. Okay, for varying values of c. And then this orthogonal family is a bunch of hyperbolas, so they'll probably be going like this. And you see they're going to intersect those curves at right angles. Okay. Okay, so let's see this sort of, yeah. Okay. Okay, so let me look at the homework and see if there's anything crazy. And let's at least do one of the homework, one of these orthogonal trajectories. I'll try number 15, hopefully. Okay, so y cubed equals c x to the 4th. So again, going through the program, first solve for c, so c equals x to the negative 4th y cubed. Differentiate implicitly, so 0 equals, take the derivative, leave x to the negative 4 alone and take the derivative of y cubed, so that would be times 3y squared times y prime, and then plus take the derivative of x to the negative 4, leave y cubed alone, so negative 4x to the negative 3 times y cubed. Make that look pretty. So what do we have? I have to solve for y prime eventually here, but 3y squared all over x to the 4th y prime minus 4y cubed all over x cubed. I try to isolate the y prime. And yeah, multiply by reciprocal. And what do we get left? So 4, it's just like 4y, and then x, 4xy all over 3. Okay. So y prime is 4xy all over 3. Then I need to take its negative reciprocal, so the new differential equation, negative 3 all over 4xy. Then I need to solve this differential equation, so multiply both sides by y, so I get y dy, multiply both sides by dx, negative 3 all over 4x dx. I'm sort of starting to get worried because it seems like in the solutions you need, did I make a mistake back here? Let me pause the video and see if I made a mistake. Oh, I see the mistake. I integrated and I added one to the exponent here. You always subtract, right? So it should be negative 5. Negative 4 minus 1 is negative 5. And then this will be 5. And then this will be 5. Sorry, guys. Where is the next one? So this guy, no, this guy is the 5. 5, and then this will be in the bottom. This will be x, and then let's just get rid of this, and sorry, and this. Okay, so then get rid of this. So my new differential equation, negative 3x all over 4y. Then we could separate, so you get y dy equals, am I recording? Yeah, okay. So you get y dy equals, and I like to leave my constants on the right, negative 3/4 x. Integrate both sides, you get y squared over 2 equals negative 3, become 8 x squared plus c. and it's a circle, right? You can multiply by 8 if you want to make it look pretty. Add the x squared to the other side, so you get 3x squared plus 4y squared equals your integration constant. Let's make sure that works before we get all carried away. 3x squared plus 4y squared equals big C. And let's just see if it works before. Yeah, that's right. Okay, and then for the graph, I would just go to, well, you know it's going to be some circles. The only question is that original y cubed equals x to the fourth. So go to Desmos. Desms. How about Desmos? And then just go y cubed and put in some random numbers for C. So 4x to the fourth, and then, you know, just, you can copy and paste it here. Tree, maybe make that a -4. So it's going to be concave up on the top. So let's see if there's one that's concave up. It's this one or this one here. They both look exactly the bloody same. So you could kind of tell by the circles which is which. So it should be skinnier in the x direction. Yeah, so it's got to be this guy. If it's not, then it's the other one. Okay, so did I get it? Oh, we still missed it. So it's probably this one then. Skinnier in the y direction. I got it. Okay. So there's that. Let's give you a video quiz. So let me do one for the video quiz. This will be the video quiz for section. This is the second video quiz. The second video quiz in the second video quiz set. So you should also have 6.2 already, and now 6.3. So I don't know which one to do. Let's try number 6. Okay, so number 6, we have 9y ln x minus xy prime equals 0. Okay, so we want to separate. So get xy prime equals 9y ln x. Get the x stuff on one side, the y stuff on the other. So I got dy all over y equals 9 ln x over x dx. And then integrate on the right. I need a u sub for ln x. du is just 1 over x dx. Or if you rather, dx is x du. Okay. Ln absolute value y equals, you can factor out the 9, then you get u all over x times dx, which is x du. So ln absolute value y is 9. These cancel, and times the integral of u du. So ln absolute value y equals 9 u squared over 2 plus c. Back subbing, we get ln absolute value y equals 9 times ln x squared all over 2 plus c. You can exponentiate both sides and get an explicit solution. So now on the left you got absolute value y. On the right you get, let's turn it into 2 factors, e to the c times e to the 9/2 ln x squared. And then drop the absolute values, you get a plus or minus e to the c, replace the plus minus e to the c with a c, and you get e to the 9/2 ln x squared. So let me mark that down as my video quiz, so don't forget. and make sure it actually works. So we get y equals big C e to the 9/2. Let's see, is ln x squared that. Yay! I want to do one more for luck. Let's try. Let's try this number 4. X y prime equals 39y. So separate, you get dy all over y equals 39 all over x dx. Integrate, ln absolute value y equals 39 ln absolute value x plus c. Exponentiate, you get absolute value of y equals, let's separate this a little bit. So you get e to the c times e to the 39 ln x. Absolute value x. You can't simplify this e to the 39 ln absolute value of x. You need to first pull that into the exponent. Okay, so you get absolute value y equals e to the c, e to the ln of the absolute value of x to the 39. Then you can simplify. So you get absolute value of y equals e to the c times absolute value of x to the 39. Then you can drop the absolute values on both sides, replace it with a plus or c on the right, plus minus on the right, and then you can replace this with a big constant, c. So you just get y equals c x to the 39. Let's see if that works. So y equals big C x to the 39. What the heck is it? Oh, there it is. Okay, so it's good. Okay, so hopefully that'll be good. We want to do one more? Let's do one more. I mean, you don't have to watch it, but I'll feel better. Number 9, square root of x plus square root of y prime is 0, and then initial condition y of 9 is 16. So I'm going to go square root y prime equals negative square root x. And then I'm going to separate and rewrite the exponents. Right? So dy equals negative x to the 1/2 dx. Integrate. So y to the 3/2 times 2/3 plus c equals negative x to the 3/2 times 2/3 plus c. And to make it look a little prettier, combine the c stuff on one side, move the x to the other side, multiply everything by 3/2. You end up with x to the 3/2 plus y to the 3/2 equals c. Right? The c's will absorb the constant, and then I just combine the c's together. Then we use the initial condition to solve out for the constant. So x is 9, so 9 to the 3/2 plus y is 16 to the 3/2 is c. 9 to the 3/2, how do I do that? That's 9 to the 1/2 cubed. 9 to the 1/2 is square root of 9, that's 3. 3 cubed is 27. Plus 16 to the 3/2. How do I do that? That's 16 to the 1/2 cubed. So 16 to the 1/2 is 4. 4 cubed is 64. And then add them together. 64 plus 27, 7, 8, 9, 10, 11, carry the 1, 6, 7, 8, 91 equals c. So I could replace that in there and write out the answer. I hope that's right. So x to the 3/2 plus y to the 3/2 equals 91. Let's see if that works. Hey. Okay, I think that'll do you. Hopefully you'll be able to get everything else. If not, get into the tutor online. The Tri-C has tutoring online. Just Google on their webpage the tutoring. And if not, you can come see me during my office hour online or in person. And hopefully that'll be good enough. Okay, thank you for watching as usual, and I'll see you next time.